Okay, we're live. Christian, Jesse, are you ready for it?
Yes.
Yeah. Hello.
Hi.
Awesome. Okay. Hello, everybody. Today we're hosting a special event on the Home Assistant channel called Power Up Your ESP-based projects. Let's get started with just some quick introductions. Who are we and why are we doing this? So I'm Paulus Schoutse. I'm the founder of Home Assistant and also the founder of Nabukasa. Home Assistant is an open source home automation platform that you can install on your Raspberry Pi or in a virtual machine in a Docker container, and it becomes the brains of your house. Home Assistant focuses on local control privacy, so the data doesn't leave your house. Nabukasa is a company that I started that provides add-on services on top of Home Assistant, and nowadays is used to fund development of both Home Assistant and also ESP Home. Joined today, we are by Jesse Hills. He's one of the core maintainers of ESP Home.
Hello.
Jesse, you want to introduce ESP Home?
Yeah. So ESP Home is a firmware that Otto Winter had founded, and it is to I don't know how to put this. A firmware for your ESP32 and ESP8266 devices that allows full local control of both switches and reading of sensors. And yeah, we're just growing the list there, but has a very great integration with Home Assistant, so you have full local control there. There's a lot of consumer-based devices out there that run on ESP8266s and ESP32s, which then allow us to install ESP Home on those devices and pull them away from the cloud, basically.
Awesome. And today we're joined by Christian Swinne, the founder of WLED, a popular open source firmware for the ESP8266 and ESP32 chips. Christian, can you explain quickly what WLED does?
Hi, I'm Christian. I'm the founder and maintainer of WLED. It is a software for the ESP8266 and ESP32 as well. And it allows for local control of various different LED strips, like NeoPixels, WS2812s, and also analog LEDs. And also it offers full local control, and it has an integration for Home Assistant. And it has many lighting effects, over 100 different modes that you can select and have your lights do awesome colors and various stuff.
Okay, thank you very much. All right, so today we're going to talk about ESP32 and ESP8266 microcontrollers. And for the people not familiar with these names and the word microcontroller to begin with, a microcontroller is a very tiny, teeny tiny computer. It has like a little bit of CPU power, a little bit of memory, a little bit of space to store something. And ESP32 and ESP8266 are types of microcontrollers. They're made by the factory, by the manufacturer Espressif. And Espressif has done something very cool in that they were able to create these chips, including Wi-Fi, which was not common in microcontrollers. And they made them really, really cheap. So you can actually order an ESP32 with including shipping for $5 from China. But of course, these are computers, and computers, they need software. And so there's a lot of software around. You know, we just talked about ESP Home, we talked about WLED. And there's kind of two categories of software when it comes to these microcontrollers. We see software there which you just need to install once, and once it's installed, you can actually go to the website hosted by the microcontroller and configure everything. You no longer need to install anything, it's just done. The other type of software or projects that we see, and ESP Home is one of those, is you have to configure or write the programming code on your computer itself. You create the software, compile it, and then install it on a microcontroller. Now, we were looking at these kind of projects, and a lot of these projects are very important for our Home Assistant user base because, you know, Home Assistant is just the brains. Every room, you might have like LED strips, you might want to send infrared commands, you might want to have sensors, and all that stuff you want to integrate into Home Assistant. So we realized, like, okay, these projects, we should be able to see if we can like make them easier to use. Because when we were looking at it and we were experiencing this with ESP Home ourselves, there were a lot of issues that we're seeing. It's difficult to install the software on a microcontroller. You need to like, it's called flashing. You do it over serial. You have to connect with a device with a cable. The second thing is then once it's installed, you actually need to configure it to connect to your local internet, which is also very difficult. And then once it's connected to your local internet, you actually need to find the IP address where it's hosting its interface so you can interact with it. So we went and we actually built a couple of tools that we're going to announce today and a couple of things to make all of this easier moving forward. So the first thing that we're doing, and we're starting to do this with ESP Home, is that we're going to start using the terminology that users understand and not per se that the microcontroller technology people use, right? So when we were looking at ESP Home, we were using words like flashing, uploading, downloading, firmware, and we realized that a lot of users that we want to get into using ESP Home, they were already kind of scared right away because, whoa, this looks really complicated. All these words, flashing a firmware, I have no idea. So one of the things that we're going to do with ESP Home moving forward is that we're just going to use the word install. And this is, people are used to the word install from installing apps on their phone or their computer. And so moving forward, install will be really helpful. And of course, things might get technical later on, and that's fine because, well, we'll, at least they get past the installation phase when they get there. The second thing that we want to announce today is a new project that we call ESP Web Tools. It's a set of tools that you can add to your website to actually make onboarding easier. And to talk more about this, I'm going to give the word to Christian, who has actually has implemented ESP Web Tools for WLED.
Yeah, I'm actually the first person to use the awesome code of ESP Web Tools for WLED, so you can easily install WLED to your microcontroller. And as you can see, it's a web page. It's available at install.wled.me. And you need, right now you need a desktop version of Chrome or Microsoft Edge for it. It doesn't yet work with Firefox, but maybe it will in the future. And as you can see, you get to this nice landing page, and then you can choose to make a clean install where it will delete everything you already have. Or if you already have WLED on there and you just want to update it while keeping your presets and settings, you can uncheck it, and it will just write a new, install the new version without deleting everything. But if you are coming from a different firmware or you are flashing a brand new unit, then I would also recommend leaving it checked so that everything gets cleaned and there will be no problems with residual stuff that was still saved on the device. Okay, now we can go ahead and install it. Here you have the selection menu for the serial port. Normally you have just one device there to select after you plugged in your microcontroller to your computer. And now you can click connect, and the ESP Web Tools will handle everything, the rest for you. Right now it's deleting what was on there previously. This might take a moment, like 10 seconds or something. And now it's writing the WLED firmware to it. This will take approximately 2 minutes, and I would highly recommend not leaving the tab while doing this, because then it will drastically slow down. And so to get a quick flash, just stay on this page for 2 minutes, grab a drink, and once you come back, it will be fully installed.
Right, so the beautiful thing of this is that previously, to install WLED, people had to either install a flashing tool, which was sometimes powered by Python. So you had to install Python, install virtual environment, install the flashing tools, and then write it. Now, moving forward, people can actually just use a browser on their desktop computer or Chromebook and just install it. It's done. And after that, you can connect some LEDs to your ESP and just configure it through WLED.
And one thing I wanted to mention, after the flashing process, it will just open the WLED AP, the Wi-Fi network WLED creates automatically, and you can configure it, for example, using your phone like you're used to. But I also, behind the scenes, we are working already on something that allows you to enter the Wi-Fi details of your home Wi-Fi right on this page, so you don't have to connect to WLED AP first, and that will be awesome. But for now, it's a little secret because we've yet to implement it. But if it works, it will be awesome.
All right, let me just switch back to. There's a lot of screens going on my end. Let me see which one.
There's a question by Koshi right now. I pronounce it WLED, so each letter separately, but you're fine to pronounce it whatever way you like. So,
right. So a little bit of like, let's say you want to add ESP web tools to your website. And so we've actually already created a couple of demos ourselves. We're trying it out. We were able to flash or install MicroPython. We were able to install Esprino. We were able to install Desmoda without any problems. And the way it works is twofold. One is that you add the JavaScript to your website. So you do this by including a script tag to your website. You can actually download the JavaScript to your own website, or you can reference a CDN called unpackage. And then it is a web component. So anywhere on the website where you want to have this install button, you can just put this piece of HTML that you see. And then that's it. It will just work. So this install button, how does it know what to install? It's called a manifest. So a manifest is a small JSON file, and you can see it below. And it will have the name of the project. So this example has ESP Home as the manifest. Then it has different builds. So the way ESP web tools work is at the moment it gets connected to your ESP device, it will actually see, am I talking to an ESP32? Am I talking to an ESP8266? Based on this information, it can pick which build to install. So the user no longer even has to know what kind of device it is or which build to map to which device. And so right now, the only selector we have is chip family. In the future, maybe we can have feature detection like Bluetooth on ESP32s or flash size. But for now, it's just the chip family. And then if you build a manifest and you need multiple files to be flashed, which is often the case on ESP32, you can actually put that all inside the manifest. And these files, this path will then be resolved relative to the manifest. So if you have a folder, in this case, firmware build, you have the manifest, you add all your files of the different builds, and then the ESP web tools will take care of the rest. There's no need anymore for any user to do anything else. So one thing you might see here already in the manifest is called Improv, because Christian was already talking about, well, once you install WLED, you also need to, it will spin up a Wi-Fi access point, and it will then connect to the internet or to your wireless network, and then you can talk to it. Well, that is the second pain point that I mentioned earlier, and that's actually something that we also have a solution for. And that we call Improv. Improv is a new open standard that we're announcing today that will allow you to set up your provision Wi-Fi on your devices over Bluetooth Low Energy. So the way this works is that we're actually we see this actually a lot already in a lot of consumer-grade devices that we can buy. The app opens, it will find the device over Bluetooth, and it will send the Wi-Fi credentials. This gives a lot better user experience because Bluetooth can give instant feedback if a Wi-Fi connection was unable to set up. Previously, we were either having to deal with something like a Wi-Fi access point, which is error-prone because a WLED or an ESP Home device will have to take their Wi-Fi access point down to actually try to connect to the new Wi-Fi access point. If that fails, spin up the access point again and hope the user is still there and interact. So Improv has support for multiple features that we need in open source firmwares. So a lot of open source firmwares are actually hosting a website on the device. And so we made sure we had support for this. Now, there are other standards that we're already allowing to provision Wi-Fi over Bluetooth Low Energy, but none of these standards were open and free to implement, or they didn't fully support what we all wanted. So here's the way it works. First, by default, a device that needs to have their Wi-Fi configured needs to have authorization required. So this, for example, can mean that you need a button to be pressed. For example, you don't want just anyone to be able to come around and let me just click this, prepare the demo. You might not want your device that anyone randomly can come around and provision it. Now, authorization is optional. It doesn't have to be. It could be that like, hey, I cannot connect to a Wi-Fi. I will allow myself to be set up. Then once you're waiting to receive credentials, the next step is you're going to be provisioning. So in this state, the device is going to try to connect to the Wi-Fi. And if that is successful, it will become provisioned. And when a device is able to successfully connect to the Wi-Fi, it will actually return over Bluetooth a URL that the user can be guided to finish onboarding of the device. So for example, in ESP Home, once an ESP Home device is added to your network, the next step is that you want to set it up in Home Assistant, because that's how you want to control it, for example. Or with WLED, you want to go to the configuration panel on the device to set up which LEDs you have attached to it. So this is all possible with Improv. So I'm going to show a quick demo now. Okay, so while I was in the previous demo, I installed a WLED on my ESP32 that I have here, and I, in hindsight, should have had 2 ESP32s ready. So I'm actually installing an ESP Web Tools demo now, powered by ESP Home, which will have Improv enabled. So bear with me while we wait a minute while this is being installed. And so ESP Web Tools has support for Improv. This means that ESP Web Tools will actually, once it's done installing the software, it will offer the user, hey, do you want to use Bluetooth to then connect your device to the internet, to the wireless network? I'm going to show that button here, but we also actually made a standalone button that you can put on your own website. And so that's over here. So I can already show you. It's now scanning for Bluetooth devices. It cannot find them yet because we're still waiting for. Oh,
of course.
This is the problem when you go away from the tab. Chrome will throttle the event loop, and so sometimes the installation fails. So, okay, well, it's great. Then we're going to launch Improv today, and we already have a few SDKs available. So the first SDK that we have available is for JavaScript. That's the one I'm going to show you right now. You add this to your website, and you can allow offering your users to configure devices. We also made an SDK in Kotlin for Android apps, and we also made a demo Android application. This was done by Justin Bassett. He builds the Android app for Home Assistant, and we're going to actually add this to Home Assistant as well in a later date. We're also planning an iOS version that will be written in Swift so that the Home Assistant iOS app can also set up devices that use Improv. But you're not limited to our SDKs. You can write your own SDK. You can put it into your own apps. Anywhere where it's possible, this can work. And then we're also having an SDK for C++, which is being used by Improv on the ESP Home. And so you can add it to any of your C++ applications. But this is all the things that we're launching today. But the specification is open so people can add it to other places. So for example, one of the places where I think it would be great to get Improv Wi-Fi added is that if you have a Raspberry Pi and you just install an operating system, and the operating system, when it boots up, detects it's not connected to the internet, well, maybe we can start configuring Raspberry Pis and connect them to the internet and interact directly with Debian and Network Manager. That's something we haven't built yet, but it's definitely something that would be very interesting to have built. So for people that are familiar with installing software on ESP devices, you might realize like, wow, through the browser, it goes a lot slower than through the command line. And this is true. This is we're still trying to see if we find any bottlenecks and if we can like tweak that, or this is something that needs to be fixed inside Chrome. We need to look into that. So that's something that's coming soon, or at least I hope we can get it faster. Right now, I think for an ESP32 it takes 2 minutes, and I think 1 minute, Jesse, for an ESP8266.
Yes. Yeah. It's a little bit
Well, it
different.
depends on the binary size, and binary size is usually smaller for the ESP8266, so it's like about half the time it takes for the ESP32.
Oh yeah, of course.
Yeah.
All right, installation is almost done. It's good. I'm running out of content.
Just hope it makes it past 99%.
Oh yeah. Boom, writing complete. So right now a new button has appeared. Click here to finish setting up your device. So I'm going to click on this. Now you can actually see it has discovered my ESP device, and it says, hey, do you want to pair with it? Now, just for the demo purposes, I'm going to show the same screen on the Improv website. So this is the exact same SDK, the same code running either inside ESP Web Tools or as a standalone. Now, I'm going to connect here. And so it will establish a Bluetooth connection with my device and be like, hey, do you want to configure the Wi-Fi credentials for your new ESP device? So I'm going to enter these. And then when I click on save, it's going to send the Wi-Fi credentials over, try to establish a connection. And if that is successful, it will then allow me to go to the next URL that the device is going to tell the browser. So the browser doesn't know how this device works. The device will tell the browser what next place the user has to go. So we're going to connect. We see now it's provisioning. This means my ESP device is connecting to the internet. The connection is successful. Now, the URL that the device returned is going to be the next step, because we can actually see in the bottom left of the corner of Chrome, it actually links to my Home Assistant. Because ESP Home, you want to set up with Home Assistant, so we're going to click on Next. And my Home Assistant is a service by Home Assistant that will allow users or allow documentation to link users to their Home Assistant installation. And because not everybody has Home Assistant on a different URL, we created my Home Assistant to allow you to get this link to your own instance. So I'm going to click Open Link. This is going to open my local Home Assistant installation. And as you can see on the top, it's going to start a config flow. So now you can already see in the background here is that ESP Web Tools has already been discovered by Home Assistant. So through the My link, it will ask me, do I want to set up a Home Assistant ESP Home? I click yes. Then it says, hey, we found an ESP Home, or do you want to set up one from scratch? I say, okay, set up the one that we found. Then it confirms again, do you really want to add this new ESP device to Home Assistant? I click submit.
Quite a few confirmations there.
That is a lot of confirmation. We might want to streamline that one. But it's done. We just installed an ESP Home device from scratch, installing the software on the microcontroller, sent the Wi-Fi credentials, and then set it up in Home Assistant. And we all did it in one flow without having to leave the browser, without having to go to the command line, restart things, etc. So this is going to be really, really cool, because it will make it so much easier for our users to get started with ESP Home or with any other ESP-based firmware that will use these tools. Because all these tools that we're announcing today, they're all free. They're all open source. Anyone can use them. So let's see. Let's change back to the slides. So for ESP Web Tools, we actually relied on the code from Adafruit. Adafruit's employee, Maker Melissa, she had built a website to allow installing firmware on the microcontrollers. Now, this was a standalone website that wasn't really reusable. So we forked that code and we made it into a reusable library that covers more use cases, including ours. And we're actually trying to work with Adafruit now to make sure it gets back to them so that there's not 2 copies of the code floating around. But yeah, Melissa did an amazing job that it works so well. Okay, let's see. Yeah, I already talked about the SDKs. Okay, ESP Home. Jesse.
Yeah, so what we've done, because we've got all of these new web tools, ESP web tools, we wanted to make the dashboard a lot easier for everyone to use. Previously, there was a wizard there, and you would enter your name and select your board and enter your credentials and passwords and all of that, and then you would compile and download the binary and flash it. Obviously, that downloading of the binary and flashing with the flashing tool is no longer required. So what we can do is we can add a new node. You only need 3 things, which is the name, the Wi-Fi password, Wi-Fi SSID and password. So just do some bad spelling here. And so there's restrictions on the name and on the input field. So if you try to type an invalid character that's not in part of the allowed character list, it'll just do it. So spaces automatically turn into hyphens and things like that. So it makes it a lot easier to follow the rules of the names. So once we've done that, we hit next. We're given an option here to connect to the ESP device directly through the web serial and ESP web tools that we've got created. Otherwise, you can skip it and do the manual compiling and downloading and installing if you really wanted to. But why would you do that anymore? So if we go to connect, we get the same dialog as before. And we go through the same process as the ESP web tools, just with a little bit of a different user interface. So preparing installation is really is the compiling of that binary behind the scenes. It takes maybe a minute or so for this step to complete. Yeah, and then I don't know. Once we've done this, you'll sort of see what happens. But yeah, I think we're gonna look at adding an option on this dialog here to be able to show the actual compilation logs for people that want to see, to make sure it's actually doing something, because right now you don't really know what's happening there. So there we go. So the compilation was successful, and now it's installing. You don't I need to get used to. It's installing the firmware, the ESP Home, onto my ESP32 through the browser. And yeah, like I said, this takes 2 minutes, so the same amount of time. Actually looks like it might be going faster than Paulus's previous demo. I don't know why. And so, yeah, so pretty much from here, we have the same experience as if you were installing from, say, the ESP Web Tools website. Your new node will be added to the dashboard. Here, you'll see it's online, and the discovery will happen in the background on Home Assistant. So you'd end up going through the same flow. We don't have the automatic linking to the My Home Assistant in this side, but you'll be able to see that the device was discovered anyway and still have the ease of setup.
Jesse, I see a question here from user Frank Nijhoff. Oh, misclicked. He asked, when will this be available for everybody? Now, basically. This was released this morning, about half an hour before the stream. So if you update your ESP Home installations, then you'll have all of this, basically. Whether you use the Home Assistant add-ons, whether you use standalone ESP Home, it's all there. New version 1.19 this morning. And there we go. So we've got a new device there. We can see the green bar at the top. So it's online on the network. And yeah. You want to show the new install dialog really quick?
This one, yes. So if you are updating one of your devices, made changes, then instead of, we previously had upload here, so we've changed all that to install, and then you can choose which one. So installing via the browser does what we just did there, wirelessly, so you don't even have to have it attached. So it's going to be the most used option, and the same as the previous option. Once your devices are installed somewhere, you just want to make changes. Via the server we've kept this there for people that still want to use it. It means that your device does need to be plugged into the machine that's running the ESP Home dashboard, which is not the greatest experience especially if you're running in a VM and Docker and all of that. And then you can just download the firmware binary if you really wanted to. Or you have like an unsupported, you can't do it via the browser. You have an unsupported browser.
So I see a question here from Andy Sawyer. What happens if it fails to connect to the Wi-Fi network?
Good question.
I guess it depends
right.
on the configuration.
Yeah, I mean, right now you would see the red. In here, we don't have the logs working via the web serial yet, but that is something that is to come. So yeah, right now it's a bit of a, don't type your Wi-Fi password wrong sort of thing. But you can always reinstall via the browser. You can make a change and reinstall that. You see my super secure password here. So you could easily change that and reinstall the firmware onto the device and do it again. You're not limited in that sense, but logs definitely will help once we have those going through the web serial as well.
Cool. Thank you very much, Jesse. All right, let me get the slides back up.
I can see a comment there from Jens. Can we add something for the colorblind in the dashboard? This is something that has come up before and then is a sort of feature request issue as well.
We'll make sure we get address that before the next release of ESP Home to make sure that we don't just use red and green, but we'll also include the text. That's definitely a good point. All right. The other thing for ESP Home that we're launching today is that we want to embrace projects that use ESP Home to ship products more. So in the last year, we saw the tech reader by Adorno. This year, Marcel is working on a energy smart meter reader for the Netherlands and Luxembourg and Belgium through the P1 port. And they're all powered by ESP Home. So we want to make sure that these projects not only have a great onboarding, which I think we've covered now, but we also want to make sure that once it's installed in the user's home, there's still this connection between the project, for example, for documentation or these kind of things. So starting today, projects can actually store the project identifier that they can make up themselves and a version inside the ESP Home configuration that they distribute on their projects. Right now, the only thing we use it for is that we show it in the discovery information when you look at when you find ESP Home device on the network. But actually moving forward, we want to make a registry of ESP Home-based projects. That way, when you go to the ESP Home dashboard, you can actually see the logo of the project, the name of the project. You can link to the project's documentation, the bug reports, and we can even start offering firmware updates through the ESP Home dashboard so that a project that finds a bug and fixes it can actually get delivered to the users. So we actually, for now, we just added a special page to your documentation. If you're creating projects on ESP Home, please check it out and add that identifier so that we can add all the cool stuff. So yeah, that's all the cool stuff that we had for today. We really, the pain points we identified earlier, installing open source software, microcontrollers, getting microcontrollers connected to your wireless network, and then visiting the IP address or configuring your microcontrollers once they're connected. All three pain points have been covered and are no longer an issue if you use the tools that we've added today. If anyone has any questions in the comments, please let us know. If it's any question for WLED, ESP Home, Home Assistant, we're here.
I saw a question previously. I don't know who it was from, but they asked if we need to select the device before installing with the web installers. And the answer to that is no. The web flasher will automatically detect whether you are using an ESP8266 or ESP32, so it will do that for you and you don't have to select anything.
Let's see. Somebody asked, can you create devices using stored secrets rather than typing Wi-Fi credentials? I think this is ESP Home related.
Not right now, but that is something that I thought of, but we just couldn't get into this release.
Yeah.
So, I think we will definitely look at that.
Part of the work we did on the ESP Home dashboard to get like these new features added is that we actually changed the infrastructure of how the dashboard is built and shipped, which should allow us in the future to more quickly iterate on it and make it easier to develop for. So I think a lot of these new features can easily be added moving forward. Let's see. Home Ace is asking, isn't there a difference between board types for pins? So this is only if you are using ESP Home, you can configure your board type still as you want. The added benefit of configuring a board type is that you can actually use aliases. So sometimes boards will have letters and numbers printed next to the pins, and you can use those in your configuration. But you should always be able to use the GPIO pin regardless of which configuration it is.
Yeah, and in WLED you can just also configure the GPIO pins freely in the web UI configuration. So that's not something you have to do in the installer. That's something you can always change afterwards.
You want to show my screen again?
Oh, yeah.
I probably should have gone through it. So if you skip this step here, when creating a new one, you'll get another dialog here. So ESP32, so generic ESP32, generic ESP36, 8266, or you can choose the previous boards here in a list. So if you really want to do it right from the beginning, you can. And they're all still there. This won't flash, won't still be a serial, but once you've got your configuration, you can then do it via the browser.
All right. Then I saw another question here. When will WLED be tightly integrated into Home Assistant? It already is. There's Frank actually maintains the WLED integration, and in the next Home Assistant release, which is going to drop in 3 weeks. 3 weeks from now, the first Wednesday of July, the new Home Assistant release will come out, and it will actually support the new WebSocket API from WLED. So that means that any change made in LED is instantly reflected in Home Assistant. So this makes it easier to write automations if you want to respond to things that happen inside WLED. So that's actually a really cool addition that is going to land next release. Let's see. There's this question. Can this be used with eFuse down the road? I do not know what eFuse is.
eFuse is sort of settings that you can set on the ESP chips outside of firmware. We don't have, we can, they can, like, the answer is they can be down the road, yes. We can set them via the web serial. But we don't have any plans for that at the moment or any sort of use cases right now.
somebody's asking what super secret stuff I sent to Dr. Z's. Actually, it's the other way around. Dr. Z's just sent me this, the Quinn LED Quad, which is a board by Quindor, Intermittent Tech. I think he's also in the chat. It actually runs WLED, and it's awesome to connect all your LED strips in the house. So now that I have this board, I no longer have an excuse not to set up my LED strips that have been kind of laying in the closet somewhere here. Let's see if there's other questions. Dwayne is asking, where can I find the documentation? That should just be on the front page once the cache is cleared, I think, Jesse.
I did clear the cache after I released. So
Okay.
if you
just on the front page. Okay, well, I think
it's down a little bit on the page. The creators.
Creators Guide. Yeah, just search for Creators Guide. You should be able to find it.
Or maybe, actually, it might have been removed with the rewrite of the front page.
Oh, that's funny. We'll
get that back.
We'll get it back. We've actually created we finally took the time to make the ESP Home website describe a little bit better. This is the wrong tab. 1 second. We finally made the ESP Home website better describe what ESP Home does. Let's see. There you go. We now have a beautiful graphic, because I think a lot of people don't realize that with ESP Home, you don't actually have to program your microcontroller. You're just configuring it, right? You can just say, hey, on this sensor is attached to my microcontroller on this pin. You hit install, it will install on the microcontroller, and that information will show up in Home Assistant.
One question I saw twice from Frank and another user was when the next WLD release is going to drop. And I don't have an exact date, but I hope that I can release 013 still in June. So not a long time anymore. And then there will be a new release.
So I see a question here from Rob about configuring ESP Home without YAML, so using a GUI. This has come up a few times, but it's not easy. There's a lot of options for a lot of components. And then you get things like the lambdas that allow you to write C++ code. And a PR is welcome, but it's not on the timeline for
I think I think it gets a little bit too complicated. So I think it will be, there's still microcontrollers. We're trying to make it as easy as possible. But when it comes to eventually, like, you're going to run into some complexity that we cannot hide anymore. I mean, if we would create a GUI, a graphical user interface, it would be something to like only support like temperature sensors or something. But then why would we even create an interface, and why not just have like a temperature sensor ESP Home project that people can just kind of pick up?
Exactly.
Yeah, that's what I wanted to say. Like WLED has a GUI for where you can change most of the settings, but it's really a lot of work to implement that. And also WLED has way fewer settings and possible devices you can attach to it than ESP Home. So WLED is custom purpose built for LED strips. And while it is possible to like attach temperature sensors and other stuff, you have to add custom code to that, and that is not configurable via the GUI. So like for a project like ESP Home that can do literally everything with each sensor, this YAML configuration is the way to go, I believe.
Yeah, YAML for live. I see a question from Frank here.
It's the same one.
This one is for you, Christian.
Yeah, WLED, right now it doesn't have Improv, like the BLE version, it doesn't have it. And I'm not yet sure if I can implement it. I would love to, but it requires Bluetooth, and that has quite a high flash memory usage, and I'm not sure if we can fit that. But as I said, we might be working on a version of Improv that works over serial, so it can get provisioned right after flashing. And if that works out, then it will work with WLED as well, just not over Bluetooth.
Yeah, I think that Improv over Bluetooth, that is great for if you're going to buy products with the firmware or the software already installed. If you're going to use a web installer to install the software on your microcontroller yourself, Improv over serial is going to be the way to go.
Yeah, the Bluetooth version for ESP Home adds about 600 to 700 kilobytes of flash usage. And it's just bringing in the Bluetooth code base, which is about 30 to 40% of an ESP32 with the 2 megabytes.
Yeah. Well, if you're gonna do Bluetooth stuff, then it's of course it's not.
Yeah,
it's
if you've already got Bluetooth, yeah. I'm working on making it sort of compatible with the ESP32 BLE tracker so that we can have both on the same ones. A lot of people seem to put the BLE tracker on the ESP32s, so this will almost add no more overhead on top.
Here's an interesting question for you, Christian. At least I think it's for Christian, from Thomas Loven.
Where did I buy that ceiling lamp? I didn't buy it. It's an own project. I ordered the metal from a laser cutter firm, and then I put WLED stripes, and it's fully, of course, it runs WLED. I can do everything with it, and I also have added analog LEDs, so it can get really, really bright as well.
Nice.
But you can build something like that as well if you're using WLED. It's quite a lot of fun.
Yeah, I'll soon know, right? Like I still haven't done WLED, but this year it's probably my goal for this year. Okay, I think we've been. It's been all the questions. I mean, yeah. Well, some questions keep popping in, but let's see. Well, this is the final question, and then I think we should wrap up. So we can all go on with our evenings and days. Last question is, will the WLED app ever support the ability to auto-update ESPs?
That's a really good question. I have a user in the WLED community who is doing a lot of work in improving WLED. It's Blazenstack. I want to give a shout out to him, and he is working on making that possible to update WLED either from a local server or also from the internet, but there are some problems with security certificates there, so mostly from a local server. Right now, it's not yet available, but it might be in the future.
Awesome. And I think eventually this might, once WLED supports this, it would be cool if we can also from Home Assistant send like, hey, we found new firmware. Do you want to install this? And just like, I think with the Shelly devices, we can send them a URL and the device itself will download the firmware and apply it.
That's amazing. I would love to support that.
Yeah. All right. I want to thank everybody that showed up today. We are all the stuff that we discussed today is live, so you can use it. We have published a blog post on Home Assistant that kind of summarizes everything we have talked about today. But otherwise, you can find it on espHome.github.io/ESPWebTools. ImprovWiFi.com has its own domain. And of course, check out our website, homeassistant.io, ESPHome.io, WLED.me. And if you like all the work we're doing for local home automation and privacy-focused home automation, make sure you subscribe to Home Assistant Cloud and support our work. I want to thank everybody and have a good day, evening, morning, wherever you are. Cheers.
Thank you. See ya.
Thanks. Bye.